today we're going to begin talking about solutions. Now, this will actually be the one time this year that I actually think that the non-honor students will be at an advantage. Okay, today we're going to classify matter. Okay, solution is a type of matter. Okay, so this is something that the non-honor students, that the physical science students did their freshman year. Okay, physics students did not do this, but it's reviewed from your middle school days. So a solution is a homogeneous mixture. A solution is a homogeneous mixture. Homo means the same. A homogeneous mixture is something that is the same throughout. Okay, it is something that is the same throughout. Yes, there we go. Typically a solution is a liquid homogeneous mixture. Okay, a liquid homogeneous mixture. So there are two main components of the solution: the solvent and the solute. Okay, the solvent, simply the thing that's present in the greatest amount, is the substance that does the dissolving. Okay, water is known as the universal solvent. Okay, water is known as the universal solvent. There we go. The solute is the thing that's being dissolved. So if you're going to make some Kool-Aid, you're going to pour the Kool-Aid into the water, correct? The Kool-Aid will be the solute. The water would be the solvent, okay? The solute is the thing that is typically present in the least amount. We're going to calculate concentrations of solutions starting tomorrow, okay? So we need to know how these things work. So types of solutions, okay? They're all possible, okay? They're all possible. Typically, for the purpose of this class, we're going to refer to a solution as a liquid homogeneous mixture, okay? We're going to refer to an alloy as a solid homogeneous mixture typically, okay? For the purposes of this class, we're going to say an alloy is a solid homogeneous mixture. Can anyone give me an example of an alloy? Bronze is an alloy. It's an alloy of copper and zinc, okay? That is an alloy. It's all the same throughout, okay? It is not chemically bonded. Ergo, it would be a alloy. Alloys are typically known for being very strong, okay? Stainless steel or steel is an alloy, okay? Steel is an alloy. Stainless steel is an alloy. Brass is also an alloy, okay? So our band people who can't play very well, I'm not going to mention any names. Gold can be an alloy. Who has a gold ring on? Who has gold on right now? Anybody? What costs more, 14, 18, or 24 karat gold? Because 24 karat gold is not an alloy. 24 karat gold is pure gold. It is pure gold. The way the carat system works is that out of 24 carats are all gold. Okay, 18 karat gold is telling you that out of 24 carats, 18 of them are gold atoms. Okay, so 18 of every 24 atoms are gold. Okay, the other are a mix of copper and silver. Okay, that's why 24 karat gold is shinier and more expensive. You can also have 14 or 12 karat gold, which tells you that 14 out of 24 are gold atoms. Okay, so gold can be an element or it can be an alloy depending on what carat it is. Okay, depending on what carat it is. Some typical things. So, an example of a gas and a gas would be air. Okay, we would refer to that as a homogeneous mixture. Gas and a liquid. Can anybody give me an example of a gas dissolved in a liquid? Soda. Soda has gas dissolved in a liquid. When you open it, the carbon dioxide spews out, doesn't it? What about a liquid and a gas? Where would be something that a liquid is dissolved in a gas? What? No. The liquid isn't dissolved in the gas in that. Go ahead. No. But sorry, my things are a little out. water vapor, fog, clouds. Okay, rain, precipitation, before it rains. What? Yeah, but it wouldn't be what's dissolved in it. Okay, you had it the other way around. Okay, you had it the other way around. What about a liquid and a liquid? What would that? Give me an example of something when a liquid is dissolved in a liquid. Huh? Good job. Ethanol and gasoline. Don't forget these notes will be taken down by tomorrow for your open note quiz tomorrow. Whatever class time starts. Whatever time class starts. I probably would. Solid and a liquid and a solid. Typically, very few of these. So if you're going to dissolve mercury and silver and tin, salt water and water, we have a lot of solid solutes and liquid solvents, don't I? That's probably what people would typically consider the most thing. And then solid and solid, steel, gold, 14 karat gold. Properties of solutions. A solution will not separate upon standing. Okay. So today you're going to classify matter. Okay. And when you're deciding something's a solution will not separate upon standing. Let me go with some other things. It will not separate when filtered. It will not scatter light. So if you shine a light through it, it will go through it. It has very small particles. Okay, it has very small particles. So give me an example of a solution. No, I don't care. Just give me an example of. When we're talking about a solution for this class, we're talking about a liquid homogeneous mixture. What? I didn't hear you. What did you say? Soda. Is soda an answer? Is that the correct answer? It depends. Why does it depend? Bingo. An unopened soda is a solution. Will that soda ever settle? No. Can you see the particles of the soda? I can't see an individual soda particle. No. It won't scatter light. It might absorb light or it might transmit light, but it won't scatter light. An unopened soda is a solution. An open soda is a suspension. Okay? A suspension is a heterogeneous mixture with large particles that settle out. Typically, when someone thinks of settling, where do you think it goes? To the bottom. That is not necessarily true. It could go to the bottom, the middle, or the top. Okay? So an open soda is a suspension because when you open it, what happens? The bubbles come up, don't they? It's not the same throughout. It's not the same throughout. There are some spots with gas bubbles and some that are not with gas bubbles. An example of suspension would be an open soda, muddy water or sand water. Okay, muddy water or sand water. Properties of suspension, they will separate upon standing. Okay, they can be separated by filtering. They may scatter light but are not transparent, and they have very large particles. So I have a question for you. Water is pure water is a compound, isn't it? Everyone agree with that? What about tap water? But what is it? Yes, you do. But what is it? Is it a solution or a suspension? We decided it's not a compound because we put minerals in it. Okay. It's a what? Why do you say solution? Does everyone agree with Whitey? Anyone want to argue with Whitey? Why do you say a solution, Whitey? What, Darian? You can. Who has a water filter in their house? Yeah. Who has most people have a water filter in their house. Your tap water, you would say, would be a suspension. Now, kind of to kind of I understand where Whitey was kind of going, is you can't see back where we're talking about. Whitey probably went with it's a solution. Tap water is a solution because you cannot see the particles. Okay, that is correct, but they will settle. Okay, if you leave and here's really the answer to the question: how pure is your tap water? Okay, how pure is your tap water? Because has anybody ever looked inside this distilled water maker? Who lives in the country out here? Anybody? How would you rate your water? Now it really changed since you went with. It's really changed since you went with city water. Okay. But this is an FYI. This is what your distilled water looks. This is what water. These are all the particles that are in water. You drink it. Okay. It does settle. Okay. Like, and I live like country water, like the water I use to water my horses and cows, that's a lot of copper in it. Okay. It's like I watered my chickens yesterday. And so like I had a perfectly transparent water. I had a perfectly transparent water, and now you can see all the copper that was in it. Okay. You can see all the copper that was in it. But like I said, this is the water you drink. I cleaned this out. This is about 2 gallons worth of water. Trash in there. I cleaned this out not too long ago. That's what's in your water. So tap water, so pure water is a compound. I heard that pure water. I mean, all water is good. I mean, like that. I think what you're talking about, where you're going with that is probably it's not pure. Okay. There's simply I would assume, but you can die of water poisoning for drinking too much water, or like if you can drink something like some water that has lead in it, or that has what? What water? This stuff? Well, now that'd be nasty. But you drank the water. You drank tap water. Okay. So pure water. Now distilled water. Would distilled water be element? Pardon me. Would it be a compound, or would it be a suspension or solution? Distilled water. Solution, suspension, or compound? Compound. Pure water is purified. Okay. I've taken all of the particles out of it. Okay. I mean, it would taste different. I mean, your food would taste different. I mean, we're programmed to what, living here. Have you ever gone anywhere and thought that, hey, water tastes funny? That's because, maybe we probably put different things in our water. There's an acceptable range of what stuff has to be in water. But, whether we're in the low range, high range, and we put fluoride in our water for our teeth. Okay. So maybe you're somewhere that puts more fluoride or less fluoride in. So it would taste different. Yes. Like I can really tell a difference, answer that question. Cooking, that depends if you're boiling it or not. Boiling would kind of purify it. But like when I go to my brother's house and make tea, I don't like to drink his tea because his water just tastes different. And I don't like to drink water, so I don't really have to drink water. But the tea would be different because the water tastes in there is different. I hate water. It's nasty. You don't drink water at all? Probably not. All right, a colloid, okay, a colloid is a heterogeneous mixture in which there are particles between that of solutions and suspensions, okay? A colloid is a heterogeneous mixture in which particles do not settle, okay? A solution, you can't see them. A colloid, you can. So colloids do not separate upon standing. They cannot be separated by filtering, okay? They will scatter light. That's called the Tyndall effect. And they have got intermediate sized particles. So give me the prime example of a colloid. Fog is a colloid. Does fog settle? Fog's just not at the ground, is it? Fog's just wherever it is. Fog doesn't settle. Can you see the particles? Is it the same throughout? You can't see the particles in fog. Or you can see fog. If you couldn't see the particles, you couldn't see fog. Jello would be another example of a colloid. Okay? Jello would be another example of a colloid. Because if you put things in Jello, can you see where it is? Can you see the particles in it? Does it settle? Does it go to the top or bottom? Just kind of stays wherever it is, doesn't it? That would be a colloid. Now, this is kind of nasty. Milk is a colloid. Has anyone ever been to a farm and actually seen fresh milk out of a cow? You can see the particles of fat. It's kind of yellow. It's kind of yellow. Now, it's kind of chunky. Why do you guys still drink milk? If you would read a milk carton, which I wish I had a milk carton in here today. If you go to lunch and you look at a milk carton, on the back of the milk carton, if you read it, it says it's homogenized. Okay? He said it right there. You're gonna go look right above the middle. It says it's homogenized. So what they've done is they've taken all the fats and stuff out of it, and that's what they use to make like butter and cream and things like that. So milk is a colloid. That milk you drink is a colloid. It's just been homogenized. Examples of these, paint. So there's just some examples of things. Smoke is a very good example also of a colloid, okay? I have a bunch of examples on there. So a colloid is a heterogeneous mixture in which particles do not settle, okay? You can see the particles. So, last thing we're talking about today, we're going to classify matter. Our first question when we classify matter, and this is what your homework is about, is going to be, can it be physically separated? If the answer is yes, it's a mixture. If the answer is no, it's a pure substance, okay? I'd probably write this down if I were you. So, the first question, to classify matter, your first question is, can it be physically separated? First question, can it be physically separated? There's one up here you can have. My bad, Logan. Aaron. Can the matter be physically separated? That's the first question. It'll make more sense if we go along. So, can I physically separate it? Can I take different parts out? Okay. It's yes or no. So you should have, can the matter be physically separated? You have a yes and a no arrow going through that. Okay. If the answer is yes, it can be physically separated. It's a mixture. Okay. If the arrow can it be physically separated? Yes, it is a mixture. If the answer is no, it's a pure substance. Okay. The answer is, we're going to go to the pure substance side of it right now. So I probably got right here in my little flow chart. If the answer is no, it's a pure substance. There are two types of pure substances. Elements and compounds. I'm not going to spend time discussing the difference between element and compound in this class. If you don't know that, you probably shouldn't be in chemistry.
You said what?
Okay, so back on the yes side. If it can be physically separated, it's a mixture. Your next question is from a mixture. The mixture you should ask, is it the same throughout? Is it the same throughout? If the answer to that is yes, it is a. I want to be a little bit less precise than that. Okay, it's a homogeneous mixture. Okay. Okay. Yes. If it's no, it's a hetero, and I'm gonna. Yeah, I can break homogeneous down in a couple different ways, can't I? I can break it down into a solution and an alloy. Typically, only one thing is classified as purely just a homogeneous mixture. What's the only thing that's classified as just purely homogeneous mixture? Air. The atmosphere. Okay. If it's a liquid, we're going to say it's a solution. If it's a solid homogeneous mixture, we're going to say it is a alloy. So if it's solid, the solid's an alloy. If it is a liquid, it's a solution. So back over here, is it the same throughout? The answer is no. That's a heterogeneous. And I can break these down into two other things too. That would be a colloid and a suspension. I can also use heterogeneous mixture. Okay. So we're going to go through and do some examples here. What's the difference between the two? A colloid has particles that do not settle. Suspension has particles that do settle. You do it 3 times. You gotta do it. Yep. You have to do that shit. 2 more times. Suspensions do settle.
How would I graph?
You have to find the averages. You do 3 times for pistachio, okay? And then find the average. Say that again, sorry. Solution is a liquid homogeneous mixture. Yes, ma'am. Solid. Okay. So we're gonna go through and we're gonna answer some questions. Do these verbally, and these are questions you're gonna ask yourself. We'll start with Tiara. Pizza.
You can start with me.
Okay, go ahead, little piggy. Pizza.
I say it's a mixture.
So the first question is, can it be physically separated? Yes, so it is a mixture.
It's not the same throughout.
You're correct. So it's not. So you left with 3 options: heterogeneous, colloid, or suspension. Yeah, I think you're correct. It is a hetero. Aiden Lane Wilson Johnson. Sodium chloride. Chloride.
Compound.
Are you Aiden Lane Wilson Johnson? It cannot be separated, so that makes it a pure substance, so it's an element or a compound. Compound. Logan Allen Whitfield. Field name be whatever I want it to be. Orange juice with pulp. Orange juice with pulp. I like it with pulp. I don't like it without pulp.
I don't like all that stuff in there.
I do.
I mean, it's almost.
Okay, go ahead, Logan. Listen. Answer these questions aloud. Ask these questions. Can it be physically separated? Yes or no? Yes. So that makes it a mixture. Is it the same throughout? It's not the same throughout because you have parts that have pulp in it, parts that don't have pulp in it, don't you? So, You're left with hetero, colloid, or suspension. Your question is, does it settle, does it not settle, or does it not apply? Does this pulp settle? The pulp does settle, so it makes it a suspension. A general rule of thumb. Anything that says shake well is a suspension. Anything that says shake well is a suspension. Anything that says shake well is a suspension. It still could be, but a rule of thumb, if it says shake well, it's a suspension. Aaron! Zay's hoodie. Can be separated physically. You think that's the same throughout? That's visibly the same throughout? I mean, I see red, I see blue, I see white, see yellow, black. I'm looking at the back of it too. So it's not the same throughout, is it? Gender heterogeneous mixture. Thomas.
Thomas Lee Murray. Is that really a real name? Oh, I didn't know that.
You didn't know that?
I was just saying Lee because that's everybody.
Thomas Lee Murray. Italian dressing.
Got it.
Would be considered suspended. Here's it would settle. Yeah, think about it, see what it looks like. Tiara! That answer your question. Benjamin Slate Blood, so here's your question. Ice water. Ice water.
Good question.
Doesn't matter.
It doesn't matter.
Water with ice cubes in it. That's ice water.
No, it can't be physically separated.
Benjamin Slate Blood, so.
Ice can, but
We're not talking about that.
So then it can be physically separated.
is it solution?
No, it's not the same throughout. There's ice cubes and then there's water. It's not a colloid. It's a suspension. Yes, where does the ice settle? At the top. At the top.
What?
Gavin Clifton. Smog.
What?
Smog. Well, smog, S-O-M-G.
What's it?
Smog is like pollutant fog that's found mostly in big cities. S-M-O-G. So, Gavin, can't be physically separated. Yes. Is it the same throughout? No. No. It's a colloid that doesn't settle. Now, I'll remind you that the Tyndall effect, when we talk about colloids, when you're driving in the fog, should you have your regular lights on, your bright lights on? If you have fog lights, put your fog lights on. But if not, you should have your regular lights on, because if you have your bright lights on, typically the fog will be kind of up a little bit, so it will scatter the light. That's the Tyndall effect. So you want to get your dim lights on so you can see better and get down underneath it. All right, last one. What do you raise your hand like that one? You want to do one? Chalk. I got a question for him too. No, it's not. Who agrees with Ben that it can be physically separated? By bringing it, it's still chalk, isn't it? So I cannot physically separate it. That would have been a trick question.
What is this?
So it makes it a pure substance.
It's an element.
Compounds is calcium carbonate. Chalk is calcium carbonate. Gums is also calcium carbonate. What else is calcium carbonate? Limestone. So today you have some homework. It's very long.
Oh my gosh.
It is probably 50